Audio Jungle.
Hi, my name is Chumpaka Amali binti Mahazir. My metric number is DE190193. I'm representing about what is the power factor, which is PF, and the connection that we will do in this activity. First of all, what is the power factor? Power factor is the ratio of working power measured in kilowatts to apparent power measured in kilovolt amperes. Apparent power, also known as demand, is the measure of the amount of power used to run machinery and equipment during a certain period. To calculate the power factor, we need a power quality analyzer or power analyzer that measure both working power and apparent power, and to calculate the ratio of the kilowatt and kVA. In easiest way, we can express in formula, which is PF equal to true power in watts over apparent power in VA, where watts measure useful power while VA measure the supply power. The ratio of the two is essential usable power to supply the power. As in the diagram demonstrate, power factor compare the real power being consumed to the apparent power or demand of the loads. The power we available to perform work, which is called the real power. Poor power factor means that you are using power inefficiently. This matters to companies because it can result in heat damage to insulation and other circuit components, reduction in the amount of available useful power, and a required increase in conductors and equipment sizes. Finally, power factor increases the overall cost of a power distribution system because the lower power factor requires a higher current to apply the load. This is the power factor correction unit, and this is the connection that we need to connect in the power factor correction unit. First of all, this is the switch, the circuit breaker, the measurement unit in digital, and the measurement unit in analog. First, we need to plug in the three-phase supply to the power factor correction unit, then switch the switches to number 1 so the current can flow. Then we need to connect the switch to the circuit breaker by connect red to red, yellow to yellow, and blue to blue. The output of circuit breaker need to connect to the load by using the same method, which is red to red, yellow to yellow, and blue to blue. The load that we use is the resistive, inductive, and capacitive loading unit. Connect it to the measurement unit digital and analog because we want to measure the power factor. So this connection is for the voltage and this is the connection for the current, so we can measure the power factor. These are the loads that we use, which are the resistive loading unit, the inductive loading unit, and the capacitive loading unit. There are 4 lines, which is R, S, T, and N. For R line, we connect it here of the resistive loading unit and connect it to A1 in the inductive loading unit. So, for the A2 in the resistive loading unit, we connect to B2, and from B2 we connect to C2. Next, for the S line, it connect to B1 of the resistive loading unit and connect it to B1 of inductive loading unit. For the T line, it started to connect of C1 in the resistive loading unit and connect it to the C1 of inductive loading unit. For the N line, it connects to C2 of resistive loading unit and it connects to A2 of inductive loading unit. In the inductive loading unit, connect from A2 to B2 and B2 to C2. Next, for the capacitive loading unit, the R will connect to the A1 and the S will connect to B1, T to the C1, and N to the C2. Connect the A1 to the capacitive loading unit to B2 and B2 to C2. The load connection of resistive, inductive, and capacitive loading unit is in star connection. And that's all for the connection for this activity. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Hanif Fatimudahlah and I'm at number CE190063. Okay, I will continue explain about the connection of the system for the power factor. So for this activity, we have conduct 2 activity. The first one which is without capacity load, and the second one which using capacity loading units. So the layout component here. So the layout component here is switch, is the current transformer, is the main circuit breaker, is the digital measurement unit, and this one is analog measurement unit to measure the power factor. So for the connection activity, we use the line red, yellow, blue, and neutral, which is black. So for the connection for this activity, we use the line is red, yellow, blue, and neutral, which is black. So for the main, go to the switch and from the switch go to the main circuit. So from here go to the digital measurement unit, which is uh, connect in parallel yellow and blue, and for the main circuit breaker, yellow and red go to the analog measurement unit, and for the current for the current from the positive current transformer go to the digital input digital measurement unit, and the output go to the analog analog digital unit, and from the side negative of current transformer go to the analog digital unit. So that's all for the connection of the signal. Okay, next for the connection resistive and inductive load. So as you can see here, we connect the parallel between these two loading units. So from the red go from the here go to the resistive loading unit and go to the inductive loading unit. Same with the yellow and blue. So next for the neutral, we are looping face to face. So from the residual unit go to the inductive loading unit. So after we done this connection, we can measure the power factor because we done power factor correction. So when we want power factor correction, we need to add the capacitive load. When we want the measure the power factor correction, we need to add capacitive load. So what you can see here, okay. Oh, from here, go to the capacity of the unit, change yellow and blue, and the neutral, we connect face to face. So after we done the connection, this connection, so we can do the power factor correction. So that's all. Next, okay, next I will continue explain about the expectation of power factor after adding the capacitor C. So to find the value of the capacitor, have the several steps. So the first step, we need to find the power, and then we need to find the required volt, required VAR. So after we find the required VAR, we need to refer the table. So this table, we need to refer this table. So we use the for this system, we use the three-phase Y connection or star connection. So for the step L greater than R, which is 1 greater than 1, we get the required VAR. For the first one is 622.4129. So compare the for this table, the VR is 714.2. This is the nearest value, and then because this is approximate, therefore we can choose the capacitor 1.32, and we can see the XC and the operation. So so the expected value the expected value for the power factor should be greater and the same than 0.95, and this step should be same for the step 2 greater than 1, step 3 greater than 1, step 4 greater than 1, and step 5 greater than 1. That's all for me. Thank you.
Hi, Assalamualaikum. My name is Muhammad Yusuf. My matrix number is CE190029. And today I'll continue to explain the conclusion. So the goal of the power factor correction PFC is to saving on the electricity bill, which power factor adjustment avoids reactive energy bill penalty, lowers kVA demand, and lowers power losses in the installation, transformers, and conductors. In addition, it also can increase available power. PFC technology use of on the low voltage side of an MV or LV transformer enhances the power available at the secondary. A high power factor improves the efficiency of an electricity installation by allowing the components to be used more efficiently. Apart of that, the installing power factor correction equipment reduce the conductor's cross-section since the compensated the system absorb less current for the same active power. And lastly, it's reduce the voltage drop. By installing a capacitor upstream of the point where the PFC device is attached, voltage dips can be avoided, preventing network and overload and lowering harmonic. So that's all for the conclusion and that's all for our team. Thank you.